Okay, so here's our warm-up for today. The first thing on this one is you guys are going to want to do what to both sides to solve this? Add 14, because it's already subtracting, right? Okay, so when you do that, you have negative 68. These cancel out, and you have 4x. Okay, now what do I need to do both sides? Divide it by 4. Okay, so this would become x, and this ends up being negative 17. Okay? Now, on number 2, this one confused a lot of people, I've noticed, because it has this negative here. If you can put a 1 there, that might help you a little bit. Because what you really need to do is to distribute the negative 1 to both of these. Okay? So this will be 5x minus 2x plus 10. After distributing the negative. Now, what can I put together here? Well, I can put together the 5x and the 2x, right? So I'll have 3x plus 10 equals 35. Subtract 10 from both sides. Then you have 3x equals 25. So what do I need to do now? Yep, divide them both by 3. So you could say x equals 25 thirds. You could also say 8.3 repeating. Number 3, what we need to do, first of all, is to distribute this negative 4. So negative 4 times x and negative 4 times 9. Okay, so this would be negative 4x and minus 36 equals 2x minus 3. Okay, now I can put these two together. 5x minus 4x is just x minus 36 equals 2x minus 3. I want to get all my x's to one side. So if I did that, I can subtract an x from both sides here. I have minus 36 equals x minus 3. And then if I add 3 to both sides, I have x equals negative 33. Yes?
You're distributing the complement.
So we got to find a common denominator. Okay, and what would our common denominator be in this case? 10, right? Okay, so what I'm going to tell you to do is you're going to take that 10 and you're going to multiply the entire equation and distribute that 10 to everything. This will allow you to get rid of your fraction. This is the best shortcut ever when it comes to fractions. Okay? Okay, so now I'm going to take this 10 and multiply it to each item in here, each term of this equation. Okay, so how many times does 2 go into 10?
5.
Yep, so I'm going to take that 2, cross it out, and make this 10 a 5 instead. Okay, so 5 times 3.
15.
Thank you, 15x. Equals, how many times does 5 go into 10?
2.
2 times. So 2 times 8.
16.
Mm-hmm. And then I can do the same thing with the next one. So this will be 78. See how I got rid of the fraction?
I see a whole lot of work. Subtract the 16.
So essentially, whatever you multiply the denominator by to get the common denominator is what you multiply the top number by, and then you get rid of the bottom number.
Yeah, so see, you got to see how many times the denominator goes into 10. So that becomes a 5. 2 goes into 10 5 times. So it'll be 5 times 3 becomes 15. So, and then that denominator goes away. Okay? And this becomes 10 divided by 5 is 2, and 2 times 8. Okay? And this becomes 10 divided by 5, which is 2, and 2 times 39, so it's 78. And by doing that, it gets rid of the denominators altogether.
Minus the 16.
Yep, minus 16 from both sides.
Negative 1x equals negative 78.
Yep, negative 1x equals negative 78. Now what do I do?
Negative positive.
Yep. So x equals 78.
That's the only example we need.
Okay, so that is dealing with fractions. Let's go on and talk about other formulas now. Solving a formula for a variable. Most formulas have at least 2 or more variables in it. Okay? And when we, for instance, this is the formula for the perimeter of a rectangle. Okay? So there's 3 variables in this, and in this case, they want us to solve for L. So I'm first of all going to rewrite it over here to give myself room because I'm going to do it for L and for W later on. So 2L, and I'm going to write it like that because my L's look like 1s. 2W equals P. I want to circle the variable I'm trying to solve for. I need to isolate that variable. So once you write this down, and if you put your thumb over the 2L, what is left on that side of the equation? 2W. And it's positive. So how would I get rid of that 2W? Yep, I'm going to subtract it from both sides of the equation. So this cancels out. And now, can I actually take 2W away from P? No, so I have to rewrite it. Now what do I need to do to isolate the L? Yep, divide them both by 2. So L ends up being P minus 2W over 2. You could also write this as L equals P over 2 minus 2W over 2. Here, let me rewrite that. There we go. Can I reduce this at all? Yeah, so I could write it as P over 2 minus W. So that's another way of writing it, but both of these are equivalent. Okay? Now, if I wanted to solve this for W instead, let's write it out over here. I'm trying to solve for this. What do I have to do to get isolate W? Minus 2L. The same exact thing. Yep, you're right. So it'll be 2W equals P minus 2L. And then divide both sides by 2. So don't let all those variables scare you. It's easy to get stopped by all those variables basically in your mind, but you're doing the exact same steps you were doing earlier with when they were all numbers. It's not any different than what you were doing. Okay? If you have an equation with no solution, what happens is you end up with the variables disappearing, and you end up with something like this. 3 equals 5. This is an example. Now, no variables, but 3 equals 5. Is that a true statement? No, it's not a true statement. Okay? So we know that that doesn't equal. So what we could say is we have no solution in this case, or we have an empty set. if we have an equation where your variables fall away, but they end up having something that is true, like 3 equals 3, that means it doesn't matter what you put in for x. You could put anything in for x and it would work. So that means we have infinite solutions. Or it's true for all real numbers. An example of that would be, first of all, this one. If I want to solve this for x, what's the first thing I need to do here? Distribute the 2. So I'm going to do that. So this will be 2x plus 8 equals 2x plus 6. So now if I subtract 2x from both sides, I have 6 equals 8. Is this a true statement? No, it's not. So there's no solutions for this. It's an empty set. Okay, on this next one, same thing. We need to distribute the 6. So if I do that, I have 6x plus 6 minus 2x. 4x plus 6 here. So what do I need to do to both sides? I guess the question should be, what can I do to simplify the right side first? Yeah, add these two together. So that would be 4x plus 6 equals 4x plus 6. Well, I can already tell both sides are exactly equal, right? But if we were to continue on, this would be 6 equals 6. So what does that tell me? Well, it tells me it's infinite solutions. I can put anything in for x and get the right answer. Okay? So for all real numbers. Okay, so that's it for today.